Hello, we're back. This is Wim,
And Stuart, good to see you again.
and today we're going to talk about remote sensing of water. As you know, water is our precious resource that we live off on, so it's really also being used to use remote sensing for detecting water and seeing where we can find it in many forms, like snow, water vapor, the lakes, the rivers. A lot of different techniques are being used to look at water and see what's in the water as well. So we can go from optical reflectance, and where different wavebands have some kind of interaction with the water. Of course, the visible has the most interaction with water. A lot of the other energies get absorbed by water, so you don't see much in the short-wave infrared, but you can see a lot in the visible, and much less again in the near infrared too. But depending on what's in the water, sediment or algae or things like that, you're gonna get different reflectances. But pure water absorbs a lot of the energy. Then of course there's a lot of other technologies out there, like sonar, LiDAR using two wavebands to quite often look at near infrared LiDAR that bounces right off the water, and then green or blue LiDAR that actually penetrates the water into shallow depths and maybe look at the bottom even, but then which they call bathymetric LiDAR basically, and it uses the difference between those two bands to get the water depths. So that's used in coastal areas quite often, and other areas where you don't have deep waters basically. Sonar is quite often used in deeper waters, so you have a sound signal, a pulse being sent out and then bounces back, and you can use to look at deep waters. Thermal data can be used too to look at surface temperatures, where water has a very high emissivity, like a black body almost, so the temperature of the surface of the water quite often can be used for a variety of applications, and Stuart can talk about a few examples there too.
Yeah, remote sensing of water has really been critical in our understanding of both pollution, climate change, and where we may have some problems. Looking at remote sensing has been a very valuable tool to look at dead zones in the Gulf of Mexico and off other coasts caused by large algae blooms, monitoring the loss of ice in the Arctic, the loss of glaciers in the Antarctic, looking at sea surface temperatures and knowing about when we're going to have a El Nino or La Nina event. It's really been of great value, and though the applications vary, the basic principles of using different regions of the electromagnetic spectrum are the same.
So, and then there's other technologies like microwave, where like a microwave or a radar sensor or NextRad is like one of these observation systems that look at precipitation. They are on the ground in a higher in a mountain range or something like that, so you actually can see these precipitation patterns, and they use like 10 centimeter microwave data to kind of observe precipitation events and things like that. So other sensors that are out there like TRIM or the precipitation measurement satellites, they also use microwave to look at precipitation all over the world. So there's satellites, there's ground stations using microwave and so on. But yeah, so you're looking at atmospheric water, you can look at the ground, you look at the water bodies, and then snow is another one of these forms where we can use temperature as well as reflectances to quantify the amounts of snow, what kind of, if it's fresh snow, if it's polluted snow with like dust maybe on top of the snow, changing the albedo. So lots of different applications and technologies that are being used to observe water in many different forms, from atmosphere to the hydrosphere to the land surfaces, depending on what you're looking at. So many applications, and I assume you're gonna enjoy reading the chapter,
Sure.
doing the problem set again, and also of course it has a lab as well. So and then a discussion forum that you can have some input to as well, I hope. So
Have a good week.
take care.